something. I meant to, but I forgot to. Let me tell you this. Thursday, before spring break, I taught this class in my trig class and loaded the YouTube videos on both of those. And then in the afternoon, taught my physical science class. That was a long class. It's a mini-term, so 2.5 hours of class, then we had a 2-hour lab, and then we had a test. The lab didn't take a full 2 hours, so it wasn't as long as some classes were. Actually, it was only a 2-hour class, 2-hour lab, and then 30 minutes for the test. So it was less than 4 hours. I've had some that have gone close to 4.5 hours. And so I went to upload that while they were taking their tests and things like that. It hadn't uploaded by the time I left, which is pretty normal. And so Friday, I was on the Birmingham campus, and I was having it upload while I was there. Well, it continued trying to upload, and then finally said, couldn't do it. So I retried. It wouldn't retry. So I had to bring it back down, start over from scratch, and try again. Before I left on Friday, it had stopped again. Okay? Well, something's wrong with this one. And then I tried again and anyway, yesterday morning, I tried it another time. It still hung up. Well, I taught yesterday morning's class, Math 125, the Cal 1. It's our 40-minute class. Well, I've done many of those, I mean, all the time. And then I taught the afternoon class, but when I came in to teach the afternoon class, the 125 wouldn't load. So I retried, and it wouldn't retry, so I started over from scratch. Went on and taught my afternoon class, and then as soon as that was over, headed to Birmingham to teach my evening class, and all the time it was trying to upload. None of those 4 classes ever uploaded. Okay, I got home, none of them were uploaded. So I tried again, or I continued trying, and finally overnight last night, 2 of them uploaded, and the 3rd one got started. Okay? So there's something wrong with YouTube also. I don't know what it is. It may be this lousy Screencast-O-Matic, but I can't guarantee either of these are going to make it to YouTube. I'm going to try, but I can't guarantee. And this is Chris. Okay. We've had computer interruptions this morning. Before we get started on 2.3, let's hit the vocabulary for 2.2. Top of page 132. The graph of a polynomial function is blank, which means that the graph has no breaks, no holes, and no gaps. What's the term for that? Continuous. Excellent. Number 2, the blank, blank, blank is used to determine the left hand and the right hand behavior of the graph of a polynomial function. Now, they use a term, I use a slightly different term. They call it the leading coefficient test. I call it the leading term test. Either one of those will work. Number 3, a polynomial function of degree n has at most how many real zeros? At most. N. Okay? And at most how many turning points? N minus 1. Always one fewer turning point than 0. It doesn't have to have n, but it has at most n. Okay, number 4. When x equal a is a 0 of a polynomial function of f, the 3 statements below are true. If x equal a is a 0 of the polynomial function f, then also x equal a is a blank of the polynomial equation f of x equals 0. It's a 0 or a solution, or several words will fit there. Number B, blank is a factor of the polynomial function f of x. It's x minus a. Remember, you subtract the a from both sides and you x minus a. And number C, letter C, point a comma 0 is an blank of the graph of f. Say again? I almost said the word. Y'all didn't catch me. A comma 0 is an blank of the graph of F. If it's a 0, where would it be? On the graph. So y is equal to 0, that's alpha of x equals 0. So that would be an x-intercept. That's where it crosses the x-axis. It's an x-intercept. So if one of those statements is true, all four of them are true. When x equal a is a 0 of a polynomial function, x equal a is a solution or a root or a 0 of the polynomial equation, f of x equals 0, meaning the y is equal to 0. X minus a is a factor of the polynomial function, and a0 is an x-intercept of the graph of f. Okay? Number 5. When a real number when a real 0 x equal a of a polynomial function f is of even multiplicity, the graph of f blanks the x-axis at x equal a. Second? No, that's odd. Even touches, but doesn't cross. Okay? The x-axis at x equal a. And when x is of odd multiplicity, the graph of f blanks, crosses. Okay, he's going to get it right. Okay, crosses the x-axis at x equal a. Number 6, a factor, x minus a in parentheses raised to the kth power, where k is something greater than 1, yields a blank blank x equal a of blank k. Okay? Okay, what it yields is a repeated root. Okay? X equal a of, what do you call k then? We use the term in the number 5 when we talked about even or odd. Number 5 mentioned even and odd multiplicity. That would be multiplicity k. Number 7, this has a lot of them. A polynomial function is written in blank form when its terms are written in descending order of the exponents from left to right. It's called standard form. And number 8, the blank blank theorem states that if f is a polynomial function such that f of a is not equal to f of b, then in the interval a to b, f takes on every value between f of a and f of b. The one we just did, intermediate value theorem. All right. Now, homework exercises here. Do all of 9 through 14. The answers for the odds are in the back, but these are really simple, easy, but they'll review what we've been talking about in the first part of the chapter. Then do any of the odds, 15 through either 15 or 17. They're both at calcchat.com. 17's at calcview.com. Do any of the odds 19 to 27. They're all at calcchat. 21's at calcview. Then, using technology, Taylor, do either 29 or 31. Okay? You can do it without it, but if you got it, try it. They're at CalcChat, I think, so you might be able to get help there. Do any of the odds 33 to 47. All of those odds are at CalcChat. 43 is at CalcView. Using technology again, do either 49 or 51. You can probably do them without the technology, but it'll be helpful to use it and learn it. Then do any of the odds 53 to 61. All those odds are at CalcChat. 59 is at CalcView. Having trouble breathing. Do any of the odds 63 to 69. All the odds are at CalcChat. 67 is at CalcView. Do any of the odds 71 to 83, they're all at Calc Chat. 73 is at Calc View. And then do either 85 or 87, another using technology. And Calc Chat may have some help there. Then do either 89 or 91, they're both at Calc Chat. 89 is at Calc View. And then do any of the odds 93 through 97. They're all at Calc Chat. Exploration, this is only if you choose to. 99 and 101 are true false, which I assume are at Calc Chat. There should be in the back of the book as well. And then there's some modeling at 103, graphical reasoning 105, think about it 107. If you want to do any of those, you certainly can. You're not required to. Okay? They're for your viewing pleasure. Okay, any questions? 2.2. Let's move on to 2.3. Polynomial and synthetic division. Okay? You might ask yourself, why are we doing this? Okay? All of a sudden, we've been trying to find zeros. Guess what? This is going to help us find zeros. That's why we're doing it. So, our objectives here are to use long division to divide polynomials by other polynomials. We'll use synthetic division to divide certain polynomials, to divide polynomials by certain binomials only, okay, and they have to be of the form x minus k. I'll talk about that when we get there. And then we'll use the remainder theorem and the factor theorem, which will be helpful in finding zeros, which is what our goal here is, okay? So let's start with long division of polynomials. And before we do this, I want to review long division of numbers, okay? So let's take, they say consider, well, let's just take a number. Whoa. 619,164. And let's divide that by 12. Okay? How do you do long division? Don't punch it in on a calculator. How do you do long division? Okay. Notice what she's doing there. Addition, subtraction, and multiplication, we always go left, right to left. In long division, we go left to right. So that's a little different, okay? And you said 12 into 61, okay, how many times? 5 times. Then what do we do? So you divide, yeah, and you multiply. You divide, then you multiply. 5 times 12 is 60. Then you do what? Subtract, okay? You divide, you multiply, you subtract. And then you do what? Bring down the 9, okay? Then you divide, 1, multiply, 12, subtract, 7, bring down the 1, okay? Divide, multiply, subtract, bring down. Divide, multiply, okay, divide again. 5 again, then you multiply, 60, then you subtract, 11, and bring down the 6. Divide again. Looks about like a 9 to me, doesn't it? And what does that give you? 108. Then subtract. 8. Bring down the 4. Second. 7. 84. And when you subtract now, you get a remainder of 0. Okay? Now, that told you several things. Number 1, that's the answer. When you divide 12 into that big old number, you get a whole number answer with no remainder. Here's something else it tells you. That tells you that 12 is a factor of that number, isn't it? Because 12 times this equals that, with no remainder. If there had been a remainder, it wouldn't have been a factor. Okay? But with having remainder 0, it is a factor. Okay? And y'all did quite well. Divide, and you go left to right, okay? Divide, multiply, subtract, bring down. Okay. So let's do the same thing with this. Suppose you're given the graph of f of x is equal to 6x cubed minus 19x squared plus 16x minus 4. And you're given the graph, and I can tell for certain, or really pretty sure, that that crosses at 2, 0. It looks like it hits it right on the nose. It looks like it either touches there once or maybe twice, somewhere in between 0 and 1. But it's hard to see for sure. Depending on your graphing, my graphing, it would be impossible to see. But this one, it looks like for sure we have a 0 or an intercept at 2, 0, right? Now, if that's an intercept at 2, 0, that means x equal 2 is a 0 of the function. Remember those 4 conditions that we had in the last section? All, if one's true, they're all true. It also means that x minus 2 should be a factor, okay? Because x equal 2 is a 0, we know that x minus 2 is a factor. Remember those 4 things, they're all the same. If 2 zeros an intercept, then these 2 things have to be true. Okay, which means that there exists a second degree polynomial, q of x, that when you divide x minus 2 into this one, you should be able to get some quotient with no remainder. Let's see if we can. Okay, we're going to do it doing long division, which I think is going to be example 1. Yep, there's example 1. So let's do it by long division. X minus 2 is on the outside of the house, okay? 6x cubed minus 19x squared plus 16x minus 4. Time out. When you're doing long division of polynomials, there's 2 things you need to be absolutely certain about. Number 1, that both the divisor and the dividend are in standard form. Remember standard form? Decreasing order to the power. 1, 0. 3, 2, 1, 0. Okay? Descending order to the power. That's the first thing. The second thing, you don't have any missing powers. 1, 0, nothing missing there. 3, 2, 1, 0, nothing missing there. If this had been 4, 2, 1, 0, we'd been missing your cube. So you have to put in a 0x cubed to make sure you're not missing any powers. Okay, so we're ready to roll here. How do you think we start? Left to right. So start here. X will go into 6x cubed how many times? X will go into 6x cubed how many times? Now, if you want to, you can do this. Let's start with the numbers. What's the coefficient here?
X.
The coefficient? 1. 1 will go into 6 how many times? 6 times. Now, x will go into x cubed how many times? X squared times. Very good. What do we do next? We just divided. Now we multiply. Okay. Remember, I thought I went over that ad nauseum. Okay. So, multiply. 6x squared times x is 6x cubed. It better be. That's why we did it. And 6x squared times a minus 2 would be a minus 12x squared, right? And then what do we do? Subtract. Now, time out again. If you're okay subtracting signed numbers, go for it. I'm not that okay with, I mean, I can do it, but I find it far easier to change signs and add. That just to me is simple. So what I'm going to do is change signs of that, and now I'm going to add. These two add to be 0. Okay, that's why we did it. Okay, when you add those two, what do you get? Negative 7x squared, and then what did we do next? Bring down the next term, plus 16x. Just like we did with numbers, now we're doing it with terms. All right, then what do we do next? We start the process again, divide. Negative 7x, negative 7x, perfect. And then we do what? Multiply. Negative 7x times x is negative 7x squared. And negative 7x times 2 is plus 14x, right? Now, again, I prefer changing signs to add. If you can subtract, okay, that's fine. This one is easy to subtract. But I'm going to change signs and add, make that a plus, and make this other one a minus. Okay, then I'm going to add. Okay, these two go out to 0. They better. That's why we did it. Oh, my goodness, the 10 o'clock scholar. Okay. CJ is here. Okay. All right. All right, and when you add, what do you get there? 2x, okay? And then what? Bring down the minus 4, okay? Now do x into 2x. Oh, I should have asked you. What do you do next? Divide x into 2x. How many times? A plus 2 times. Always put a sign in between. These are terms now. And then you do what? Multiply, and what does that give you? 2x minus 4, and guess what? No remainder. So we were right. X equal 2 was a 0, making x minus 2 a factor, and since you come up with a 0 remainder, it is a factor. And guess what that means this is? That is the other factor of your cubic polynomial. Now, if I had asked you to factor this thing, what would you have said? Huh? No way? Can't do it? But yes, you can. If you found a 0, then you found a factor when you divide that. Now, if I ask you to factor that thing, hopefully you'll say, oh, I'll give it a try. All right? So let's give it a try. Okay? Will that factor? 6x squared minus 7x plus 2. I don't know if it'll, I do know, but, okay, what would you try first? What's one possible factorization for 6x squared? 3x times 2x. Let's try that one. This is trial and error. Where do we look next? The sign of the last term. What is it? Positive. What does that tell you about these two signs? They both have to be the same, and since the middle sign is negative, they both have to be negative. Now, what's the possible factorization of 2? Say again? 2 and 1. Let's try it. Okay? Now, this is all trial. You got to make sure. Yeah. Stupid chair. I hope I didn't trash my computer. I need to get up out of the chair and not be rolling around. But I'm not. Okay. Let's try it and see if it works. 3x times 2x? 6x squared. All right. Okay, there. Minus 3x minus 4x minus 7x. That works. And minus 2 times minus 1 is plus 2. Yes, we got it right the first try with no error. Okay, what does that tell us? You set that equal to 0, and what does that tell us? Either either 3x minus 2 equals 0, or 2x minus 1 equals 0. Right? Well, what does the first one tell us? What can we do with it? Add 2 to both sides, and then that gives you 3x is equal to 2, divide by 3, and you get x equal 2/3. And over here, add 1 to both sides, and that gives you 2x is equal to 1. Divide by 2, and that gives you x equal 1/2. Now let's go back and look at our picture again. Is it conceivable that this first point is x equal 1/2 and the next one x equal 2/3? Yes, that looks pretty reasonable. So those are the other two zeros. If they're factors, then the x equal has got to equal a 0, which is a x-intercept. All right. So that's how you factor by long division. Okay? Let's erase this and see what they do. Well, they do pretty much like we did. You do x minus 2 into that big old long polynomial here. The two things to watch for: be sure you're in descending orders of your powers, in other words, your standard form, both out here and in there. Secondly, that you're not missing a term. 3, 2, 1, 0. 2, well, 1, 0. Not missing any terms. Then start. Now, they indent this. I don't like doing it. I like doing it right over there. They do it over here. It doesn't matter where you do it. Just do it, okay? But x will go into 6x cubed, 6x squared times, then multiply 6x squared times x, 6x cubed, and 6x squared times negative 2 is negative 12x squared. Now they just show you're subtracting and going. To me, it's easier to change signs than add. It just is easier to see and less likely to make mistakes, in my mind. I've been teaching this a long time. I found that usually is that. And then you get a minus 7x squared here, because these go completely away when you subtract or change signs and add. And then you deal with this negative 7x. Bring down your next term, and x will go to negative 7x squared, negative 7x times. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is plus 14x. Then subtract. Now this is pretty obvious. That goes to 0, and that goes to just 2x. Bring down the minus 4, and then x will go into 2x plus 2 times. Multiply 2x times x. 2 times x is 2x. 2 times negative 2 is negative 4. When you subtract, you get a 0. Meaning that is a factor. This is your other factor. If that's a factor, and let's see if we can get our zeros. Okay? Now they tell you what to think up there. If that helps you, think that. Okay? I think we probably were. And it tells you what to multiply. I think we were doing that. But if it helps you to write it out, write it out. Okay? Any questions on that? Now that was the first part of what they said. That then said, find all the zeros. So from that division, and the fact you had 0 remainder, that means this is a factor, that's a factor. Now, if you can factor this further, you have additional factors. And sure enough, you can. This will be 2x minus 1, we did it the other way, and 3x minus 2. They got the same factorization. We already know x equal 2 is a 0. This gives us x equal to 1/2, and that gives you x equal to 2/3. But here's how they show it. Now, well, they didn't do much more, but we did it, okay? We're almost out of time. Let me see if I can find where this is. Okay, we'll start next time with this slide here, which doesn't really say a lot, but it's a good review when we come back next time. But we did it far enough along you can do some homework exercises. And the question has been asked before a couple times a day. The quiz will be at the end of this section, which means I'll probably have it ready for you on Thursday, because we should get most of this section done. Okay. You can do number 7 for sure. Okay? I don't know. No, we didn't. No, let's not. We'll just pick up those next time. You got plenty from the last section. Okay. Good deal. Any questions? All right. We will see you then on Thursday. I'll try to have the quiz ready then.